Assalamualaikum to all students. So we are now in chapter 2, distillation process. So chapter 2, distillation process is also one of the example of separation process. So in chapter 1 we already learned on the basic theory of the separation process, which is the mass transfer. Now we are going to apply those concepts in several example of separation process. Okay, this is one of the examples. Okay, example number 1 is on distillation process. Okay, so in this chapter 2, we have 7 topics we are going to cover. I think we are going to cover until 6 topics. Okay, so the first topic will be on definition and the general description of the process, and number 2 will be on the physical concept of distillation, and number 3 will be on the vapor-liquid equilibrium relationship, and topic 4 we will learn on the relative volatility. Okay, number 5 we have 2 types of batch distillation, so topic 5 and 6 will be on the batch and continuous distillation respectively, and 7 is the multi-component distillation. Okay, this is the course outline for this topic. Okay, let's see, this is as a whole on chapter 2. So chapter 2 we have 2 types of distillation, which are batch and also continuous distillation, and we will learn some of the theories on distillation and vapor liquid equilibrium, VLE. Also we will learn on azeotrope condition, relative volatility, and also the reflux. Okay, so this is all the terms that are very important in chapter 2. Okay, for the calculation we have the batch calculation. Okay, so usually for batch calculation we will calculate the composition of the component. Okay, and for continuous calculation usually we will calculate the number of stages. Okay, so next, let's see what is actually the definition of the distillation process. Okay, so in chemical industry, distillation process is very common, it's very important. Okay, so as I mentioned in chapter 1, so all chemical that we, for example, we have crude oil. Okay, so the crude oil usually exists in a form of mixture, so we have to separate the crude oil into each corresponding component. Okay, so in order to separate them, distillation process is common process used to separate the mixture into each component. So in distillation, a feed mixture of 2 or more components is separated. So we should have a mixture. Okay, the mixture of 2 or more components. It can be 2, it can be 3, or it can be more. Okay, so the mixture is separated into 2 or more products. Okay, depends, including or over limited to an overhead distillate. So when a mixture, for example here we have a feed stream. Okay, the feed stream will have the mixture. So the mixture will be separated, so the product will be, we call it as a overhead distillate, and the bottom we call it as a bottom product. Okay, at the top we call overhead distillate, so at the bottom is we call bottom product. Okay, which are the composition of bottom and overhead are differ from the feed. Okay, because of you should have overhead distillate and bottom product with components which are not similar with the feed. For example, if we have 100 kg of component A and B, so in distillate and product, those 2 products will never have 100 kg of component A and B. Okay, so that is the definition of the composition differ from that of the feed. Okay, so the feed is a liquid, so the feed stream it can be liquid or it can be a vapor liquid mixture. Okay, and the bottom product is almost always a liquid. So the bottom one will be the liquid, and this distillate may be liquid and also a vapor or both. Okay, so this is the important term that you should know in distillation process. First, the feed is in form of mixture. So when we separate by applying heat to the feed or the mixture, so the mixture will be separated into overhead distillate and the bottom product. So the bottom and overhead both have different composition with the feed. Okay, as I mentioned before, and the overhead distillate, the feed stream, it can be liquid and it can be vapor liquid mixture. Okay, and the overhead distillate, it can be liquid, it can be vapor, or it can be both, but the bottom product is always a liquid. Okay, so this is all the general description for a distillation. I think this is just repetitive from what I had mentioned before. Okay, so the feed, two or more components, so the product, we call it as overhead, and the bottom, okay, the bottom, the feed, it can be liquid or vapor liquid mixture. Okay, so I want to explain some additional information here. Okay, the mixture can be separated with distillation if the component of the mixture have different boiling point. So this is the most important point in distillation process. Okay, for example, if we have component A and B in a mixture, so the component A and B should have different boiling point, so that when we apply heat, both can be separated. Okay, so the substance in the mixture with the lowest boiling point will vaporize first. So for example, we have component A and B. A have a boiling point of 50 degrees C. B will have boiling point of 100 degrees C. So A will be vaporized first. Okay, so when A vaporized first, it will become vapor and condensing them to attain the original component. Usually those components which vaporize first, it will be at top. Okay, so this is example that I mentioned to you before. Okay, so this is crude oil. So crude oil, we will apply heat. Okay, furnace is the is the unit operation to apply heat. Okay, we will do heating here. So the crude oil will be heat up, okay, at a certain temperature, and we know that crude oil is a mixture of many components. Okay, so when we heat up, the crude oil will be separated into its component. Okay, let's look here. Okay, when you see fuel oil here, so fuel oil will have 370 degrees C boiling point. Okay, so diesel will have 300 degrees C, kerosene 200 degrees C boiling point, while gasoline will have 150 degrees C as a boiling point. So all those components should have different boiling points, so that when we apply heat, those will be separated. Okay, as I mentioned before, for example, here we have gas. Okay, gas with the lowest boiling point, which is 20, will be at the top. Okay, those who are with highest boiling point will be settled at the bottom. Okay, so this is the physical concept of distillation. So distillation, you should have feed, okay, and you should have a column. Okay, feed you can draw here or you can draw here. Okay, it can be at any way, either at the right or at the left of the column. So this is the distillation column. So the one that you saw here, this one is the stages. Okay, later on I will teach you on how to calculate the stages. Okay, when we have feed here, so it will heat up at certain temperature, and the product or the component which has the lowest boiling point will vaporize first. It will leave the tower or the column at the top. Okay, so when the gas will vaporize as a gas, in form of gas, it will be condensed, and it will be condensed, and it will be turned into liquid. So the liquid either we will collect as an overhead product, or we want to recycle inside the column, or we call it as reflux. Okay, reflux means we recycle the liquid here. The condensed gas will become liquid, so the liquid will re-enter the column and will undergo the process all over again. Okay, so while the component which has the highest boiling point will settle at the bottom. Okay, it will leave the column at the bottom, and it will be reborn here, and it will be we can either collect as a bottom product, or we can recycle in form of vapor here, and it will enter the column all over again. Okay, so this is the physical concept of distillation process. So I think the basic thing that you should know is feed. Okay, the bottom and or the overhead product, and reflux. Okay, at the top, because of the component leave as a gas, so we should have condenser here. Okay, at the bottom, usually the product will be liquid, so we should have reboiler to reboil, or to reboil the liquid so that it can turn into vapor. Okay, so this is all the term that you should know. So this is all the pictures showing the distillation column. Okay, usually distillation column is very big because of it depends on the product, it depends on the what you want to separate. Okay, so usually in Petronas plant or Shell, okay, they have a very big one. So because of the crude oil comes in very huge volume, so they need to separate in huge volume, so they need to have a big size of column. Okay, so next we will see on the vapor liquid equilibrium, why we have to study this. Okay, so vapor liquid equilibrium actually is the very important understanding, or very important fundamental in distillation process, because of, as I showed to you before, the component the mixture can be in vapor liquid equilibrium, and you should know that. Okay, for example here, okay, you should know that when we have a feed entering the distillation column, we will heat up the feed. Okay, so when we heat up the feed at the certain temperature, so the feed, the mixture will turns into liquid and vapor. Okay, so in this distillation column, it has the mixture of vapor and also liquid. So we have to study the vapor liquid equilibrium as a very important fundamental, because when we have a mixture of vapor liquid, so we have to study the data, because we have to know the behavior of component A in liquid. We have also to know behavior of component A in vapor. Okay, so for example, we have feed as a component A and B. So when we heat up, A and B in distillation column will exist as both liquid and vapor. Okay, so we have to know the behavior of we have to know the vapor liquid equilibrium data. Okay, so liquid in enclosed container evaporate. Okay, for example, if we have feed entering the distillation column as a liquid, so when we heat up, it will evaporate. Okay, so it will become a vapor, so it will accumulate inside the column or the container. Okay, so the vapor cannot go anywhere. So when sufficient amount of vapor accumulate, so a portion of the vapor begin to change back to its original liquid state. We call it as condensation. Okay, so this is what I said just now. So for example, if we have component A and B entering the distillation column, okay, we heat up the mixture. Okay, for example, so the liquid, the mixture in form of liquid, so it will evaporate. Okay, when we apply heat, it will evaporate and it will become vapor. So vapor will accumulate, and a portion of the vapor, okay, will change into the liquid. Okay, that's what we call condensation. Okay, while the liquid still evaporate, okay, so the process will continuous. Okay, so the liquid will turn into vapor. When accumulate, okay, sufficient amount of vapor accumulate, the portion of the vapor will turn back into liquid. So it will have two process. We call it as evaporation and condensation. Okay, so in sufficient time, at certain time, so it will we will have an equilibrium state. We call it the rate of evaporation is equal to rate of condensation. This is what we call as equilibrium state. Okay, so that's why we call it as vapor liquid equilibrium. Okay, so to calculate the rate of evaporation A, so actually the rate evaporation of A is equal to rate condensation of A because of it occurs concurrently. Okay, it occurs simultaneously. Okay, so the rate of evaporation A, B is equivalent to rate condensation B. Okay, so bear in mind, so X is the mole fraction of liquid, Y is a mole fraction for gas. Okay, so this is we maintain this term from the mass transfer chapter 1. Okay, so actually this vapor liquid equilibrium data has been studied by many engineers and scientists, and it has been tabulated in Paris Chemical Handbook. Okay, for example, if we have methanol and water mixture and we want to distillate the mixture, so actually we already have the vapor liquid equilibrium data. So this is the data, okay, that I mentioned before. For example, if we have component A and B, A is ethanol and B is water. So at this vapor liquid equilibrium data will show you at certain temperature, okay, at this temperature, what will be the portion, the mole fraction of component of the liquid and vapor. Okay, so this one they will focus on component A only. Okay, because of we want to separate. For example, if you want to separate ethanol and water, so we should only focus on ethanol. Okay, so when this vapor liquid equilibrium data is tabulated, so at this temperature, at certain temperature, okay, we already know the value of the mole fraction of A in at each temperature here. Okay, so we can tabulate a graph actually. Okay, so this is also example. So vapor liquid equilibrium data for hexane octane system. Okay, so when hexane octane system, so automatically hexane is component A, octane is component B. So we are only interested with component A only. Okay, so this is the temperature. So at this each temperature we know the fraction of the component A in liquid and also gas. X is liquid, Y is gas. Okay, same goes like this one. So this is benzene and toluene system. Okay, so the vapor liquid equilibrium. Okay, we have when we have those data, okay, this data, so we will tabulate, or we will construct a graph with this data. Okay, so it will become this data. Okay, this is temperature. So at the respective temperature we will construct a graph by using the mole fraction XA and YA. Okay, so when we construct, we will have this curve, these two curve. Okay, these two curve. So these two curve, okay, the curve at the top here, so we call it as a saturated vapor, while the curve at the bottom is the saturated liquid. So things, a fraction that inside this curve is actually in term of, it is in mixture of liquid and vapor. Okay, this is what this graph is all about. Okay, it's telling you that when we have these two curve, okay, so outside of this data, that outside of this curve is actually vapor region, or it exists in form of vapor. So data that fall below this curve is in form of liquid. It is liquid region. So data that falls in between this curve are mixture of liquid and vapor. Okay, we also call it as a dew point, and it is also called as a bubble point. Okay, the curve at the top we call as dew point. So at the bottom we call it bubble point or saturated liquid. Okay, so later I will show you in the class how can we construct this graph. Okay. Okay, what is bubble point and what is dew point? So bubble point is when the liquid start to boil. Okay, the bubble point is when the liquid start to boil. Okay, when this is the curve, okay, the bubble point, so up from this curve, so it is where the liquid start to boil, to become vapor. Okay, so for dew point, data outside the dew point is when the vapor start to condense. Okay, so this is definition for the dew point and the bubble point. Okay, so for the vapor liquid equilibrium, so we will learn on two types of law. Okay, Raoult's law and Dalton's law. So we will see what are the difference between Raoult's law and Dalton's law. Okay, from these two equation or these two law, we will construct a equation. Okay, later on, so that we can calculate on the mole fraction for component A and mole fraction for the component B in terms of liquid and also in terms of gas, or we call it vapor. Okay. Okay, that's all. Thank you.